lab11, I analyzed Felix and Baumgartner's descent from space. I was able to get some data from this jump. The initial height that he jumped from was 3,900 meters. His mass was 70 kilograms. This is the mass of an average man, not counting any of his extra equipment. And his max velocity was clocked at 377.12 meters per second. And his final velocity would have been roughly 5 miles per hour, which is 2.23 meters per second. And initially, he was not moving. I was also able to gather his total time of descent, which was 543 seconds, the time before and after his parachute opened, and the height that his parachute opened, which was 2,567 meters. From this data, I was able to calculate the force of gravity by using the formula G equals mass 1 of Felix times mass 2 of the Earth times its distance from the center of the Earth to Felix's position. At maximum height, the force of gravity would be 678 newtons. At the halfway mark, it would be roughly 682 newtons. And at the ground, it would be 686 newtons. I was able to calculate air resistance, which is 1/2 c times density times surface area times velocity squared. C I found to be 0.5, and the densities would vary from your height. So at the very beginning of his descent, density would have been very minimal compared to the sea level. And surface area will be 1.89 meters squared, and the velocities would be the three velocities: his initial, his final, and his max velocity. And I was able to find that his air resistance would be greatest at his max velocity. And I used it divided by mass to find the acceleration, which would be highest where the force of air would be the smallest, which is at the initial height. Roughly 1,300 meters above the ground would be the latest that Felix could have released his parachute without it. He broke the sound barrier by 37 meters per second. I was able to calculate using the energy principle to find the height required to break the sound barrier at that speed, which would be 12,114 meters. The change in density was a major factor in the formula. If there was no change in density, then someone could fall at 3,131 meters and break the sound barrier. And however, if there's no density, the forces would be much different. The forces would be quite higher. It would be 60,843 newtons. I found the change in temperature. If there is no change in density, to make things simpler, I used the energy formula, and I was able to find online that the C, which is the heat capacity for humans, is 3.5. And I was able to find a very high change in temperature. With the Python code, I was able to simulate what would happen using this model, and I was able to show that Felix would fall towards the Earth at an increasing rate until he finally hit the ground. However, I did not incorporate for his parachute, since this is just a science of someone falling that high. These are the rounded results that Python gave me, which is identical to the results that were found in the data. In conclusion, a 70-kilogram man would fall at 377.12 meters per second if he fell from 3,900 meters. The force of gravity is 682 newtons, where force of air pushing against him will be 348 newtons. He would accelerate to 9.69 meters per second squared, and the latest he could release his parachute would be 1,305 meters before he would die. And the height to break the sound barrier is 12,114 meters. And with a change in density, this entire formulas are altered, so it is huge in determining the physics behind this. And the change in temperature also affects the energy and the forces.